Hello, ladies and gentlemen. Today we're going to look at functions as infinite series. Please recall that 1 plus r sub 2 plus r sub 3 plus r sub n is where a sub 1 equals 1 is a geometric series with a common ratio of r, and that it will converge to a sub 1 divided by 1 minus r if the absolute value of r is less than 1. And if you replace r with x, you get the summation in that series, the summation from n to infinity of x to the n, equal to 1 plus x squared plus x cubed plus x to the n, which would be 1 divided by 1 minus x for all absolute value of x's that are less than 1. Okay, all right. Now, an infinite series of that form, where x and a sub n can take on any values for n equal to 0, 1, 2, is called a power series in x. All right. Use the summation from 0 to infinity of x sub n to find a series representation of g of x is equal to 1 over 3 minus x. Indicate the interval on which the series converges, and use a graphing calculator to graph g of x and the 6 partial sum of its power series. Okay, well, let's start with g of x is equal to f of something. Let's call it u. All right, well, we know what g of x is. That's 1 over 3 minus x. Well, f of u has to be equal to 1 divided by 1 minus u. And we can solve this for u and find what we're looking for here. All right, by just taking the cross products, 1 minus u is equal to 3 minus x. And then solving that for u, so negative u would be equal to 2 minus x. Multiply everything by negative 1. U would be equal to x minus 2. All right? And what that means is this. All right? That means that g of x is equal to f of x minus 2, which is equal to the summation, all right, from n equals 0 to infinity of x minus 2 to the n. All right. For x minus 2, the absolute value of x minus 2, less than 1. All right, now that'll give you the interval on which it converges, by the way. And what that means is that x minus 2 is between 1 and negative 1. And if you were to add 2 to each part of that, all right, you'd solve it for x, and that would mean that x is between 1 and 3. So that's the interval of convergence. Okay, we're to ask, find the interval on which the series converges. That is the interval on which this power series converges. Okay, and we'll look at that on a calculator in just a minute. Okay, in fact, let's go ahead and look at that right now. All right, if we were to talk, well, let's do that. Let's do the 6 partial sum, and then we'll talk about it, okay? All right, the 6 partial sum of this particular, so s sub 6 of x would be equal to the summation from n equals 0 up to 5 of the power series x minus 2 to the n. All right. Now, if we put in a 0, that'd be x minus 2 to the 0, all right, which would be 1, all right. So x minus 2 x minus 2, x minus 2 plus x minus 2 to this, if we input a 1, this would be 1. 0, 1, we're going to add the 6, what was it, the 6 partial sum? So the first one's here, the second one, the third one would be squared plus x minus, that's supposed to be minus 2, x minus 2 cubed plus x minus 2, 1, 2, 3, 4, 5, and 4th power, okay? All right. And now, what we'll do is we'll put in, we'll just find the series. Okay. Well, actually, it wants us to graph it, so let's graph it. Okay, so we'll graph this. All right. We're going to graph, excuse me, 1, let's go in here, y equals 1 divided by, well, actually, x minus 2 to the n, excuse me. Let's put in x minus 2 to the nth power, the x power, and then we'll come over here. That's 1, so that would be 1 plus, in parentheses, x minus 2 plus, in parentheses, x minus 2, close parentheses, squared, plus, in parentheses, x minus 2 to the third power. All right, to the third power. All right, come out of that power, plus, in parentheses, x minus, so 0, 1, 2, 3, 4, that would be to the fifth, okay, x minus 2, and we're going to raise that to the fourth power. To the fourth power, all right, and what I'm going to do is I'm going to make this second one appear thick so you can see it when it comes in, okay? All right, so that would look like that right there, and here comes the other one, okay? Oh, my, I think I need one more in that. I think I need the fifth power. Let's go down to that power series down there and go to the fifth, plus, in parentheses, x minus 2 to the fifth power. Okay, that would give us our sixth one. Yeah, I left one off, didn't I? And now when that second one comes in, it's going to really get close to the original, all right, pretty close, as we converge from this, on this interval here from 1 to 3. Okay, and if you want to write it like this, 1 to 3 is when it converges. Okay, all right, and there's what we would look for is, oops, I need to add to that, x minus 2 to the fifth power. Okay, all right, let's turn the page. Exponential series. The power series representing e to the x is called the exponential series and is given by e to the x is the summation from n equals 0 to infinity of x to the n divided by n factorial, which is 1 plus x squared divided by 2 factorial plus x cubed divided by 3 factorial, which is convergent for all x, all right? And the instructions say for example 2, say use the fifth partial sum of the exponential series to approximate e to the 1.5. Okay, so e to the 1.5, all right? And by the way, e to the x is equal to, as it says up here, is approximately, I should say, 1 plus x plus, we're going to do for the fifth one, all right? So we would do, so the fifth partial sum would be x plus x squared divided by 2 factorial plus x cubed divided by 3 factorial plus x to the fourth power, oops, that's 4, divided by 4 factorial, okay? All right, so there we go. That's what we will get, all right? And we're going to use that series to approximate e to the 1.5. That would be 1 plus, okay, x is 1.5, so 1.5 plus, all right, 1.5, all right, squared divided by 2 factorial plus 1.5 cubed divided by 3 factorial plus, where are we at right here? 1.5 to the fourth power divided by 4 factorial. All right, and let's put that in our calculator. Let me find my calculator. Where did I put it? Oh, there it is. Okay, we'll put that in our calculator. Okay, so 1 plus 1.5 plus, can you see that? I think you can see that, can't you? Yes, you can see it. Okay. All right, we got a fraction, alpha y1, 1.5 squared for the numerator, and 2 to get the factorial button, 2 math, probability 4 is your factorial. Okay, come out of that fraction, add another fraction, alpha y1, and that's 1.5 to the third power in the numerator, and 3 math probability 4 for your factorial button. All right, come out of that and add to that yet another fraction. All right, and 1.5 to the fourth power, all right, is the numerator, and 4 math probability 4 is your factorial button. And of course, when you hit enter, you're going to get 4.398. That's that would give you approximately 4.398. All right. If you were to take your calculators button and do, let's see, where's the E? There's your E to the power of 1.5. You'll see that you get something very, very close to that. Not exactly, but if you expand this further and go more, greater partial sums, you'll get closer and closer and closer. Okay. All right, we do have power series for the cosine and the sine, and the power series representations for the cosine and for the sine are given by the cosine of x is equal to the summation from 0 to infinity of -1 to the n times x to the 2n divided by 2n factorial, which is also equal to 1 over x squared divided by, 1 minus x squared divided by 2 factorial plus x to the 4th divided by 4 factorial minus x to the 6th divided by 6 factorial plus x to the 8th divided by 8 factorial minus, of course, then on the next one there. Okay, and if you notice, those powers in the numerator are your even numbers, and so are these factorials down here. All right, so that's for the cosine. For the sine, the sum is, the series is the summation from 0 to infinity of -1 to the nth power times x to the 2n plus 1 divided by 2n plus 1 to factorial, all right? And it's x minus x cubed divided by 3 factorial plus x to the 5th divided by 5 factorial minus x to the 7th divided by 7 factorial plus x to the 9th divided by 9 factorial, and so on. All right. The instructions here say use the fifth partial sum of the power series for the cosine to approximate the value of the cosine of pi over 7, round to 3 decimal places. Okay, well, the cosine, recall that the cosine of x is equal to 1 minus x squared divided by 2 factorial plus x to the 4th divided by 4 factorial minus x to the 6th divided by 6 factorial plus x to the 8th, okay, we're doing 5. 1, 2, 3, 4, 5, x to the 8th divided by 8 factorial. All right, in this case, we're going to find the cosine of pi over 7, which would be equal to 1 minus pi over 7 squared divided by 2 factorial plus pi over 7 to the 4th power divided by 4 factorial minus pi over 7, to the 6th power divided by 6 factorial plus pi over 7 to the 8th power divided by 8 factorial. Now, if I were doing all this in my calculator, I would store pi over 7, okay, because you're going to use that every time except for the first term. All right, so that's what I'm going to do immediately. And that way I want to type it in every time. All right, so I'll store that in for x, so store x. All right, so if I want to approximate this using this fifth partial sum, I would do 1 minus, I'm going to do, I don't need a fraction bar because, I'm going to go ahead and do it. I might as well. All right, because we have that factorial, so it might be a wise thing to do. So x squared is that numerator, and 2 math probability 4 is your factorial button, and we're going to come out of that one, and we're going to add to that another fraction. All right, and that one is x to the 4th power. Now, let's go back. That 2 doesn't look like a power over there. I'm going to go back and make sure that 2 is a power. Okay, that should have been x to the 2nd power. All right, now it looks more like one. Okay, now come down and divide that by 4, math probability 4 to get that factorial. All right, come out of that fraction and decrease it by yet another fraction. And this one is going to have x to the 6th power, so x, which is still pi over 7, to the 6th power. Come down below and divide that by 6, math, probability, 4 to get your factorial. And one more term here, we're going to have plus another fraction, and this one is going to have x to the 8th power divided by 8, and to get the factorial, math, probability 4 will give you your factorial. All right, and then we'll hit enter. And if we round that to 3 decimal places, that would be 0.901. All right, so that would approximate, the cosine of pi over 7 would be approximately 0.901. All right, using the fifth partial sum, 1, 2, 3, 4, 5. Okay, now, by the way, your calculator does that internally when you type it in. Now, let's see, if you were to type in the cosine of pi divided by 7, now, let's make sure we're in radians mode, which I am, okay? All right, because I didn't want to show you something that wasn't correct. When you hit enter, it should be close to 9.01, which it is, okay? All right, that's how we use Power Series. If you have questions, please give me a call, show up in the Google Meet, or email me. Thank you. Have a good day.